Hi, I'm Steph Chavez. Today we're going to talk about designing IMS PCBs. IMS stands for insulated metal substrate. When it comes to PCBs, especially regarding the design of it, the stackup is the foundation. The material that's used in your PCB stackup plays a significant role in the overall characteristics and the performance of your PCB design. An IMS PCB is a great alternative to a standard FR4 PCB, especially with having to mitigate and manage large amounts of heat in your design. I always highly recommend that you consult with your fabricator before you choose and finalize your PCB stackup within your design. An IMS PCB, also known as a metal core PCB, is a term used to describe PCBs that are made with a metal plate, typically aluminum, as structured reinforcement. This reinforcement is separated between the dielectric layer and the copper conductors of the circuit. The circuit's heat is conducted or transferred to a metal substrate via the dielectric layer within the overall PCB stackup. The metal base serves as a heat sink and a structural foundation. IMS PCBs are usually found in compact circuits with high heat generation. A good example is an LED PCB. There are primary advantages of using IMS PCBs: support structure, electromagnetic shielding, thermal conductivity, fire resistance, and SMD compatibility. IMS PCBs have various uses such as LED technology, power electronics, automotive industry, and solid-state relays. Depending on the metal substrate, there are typically three IMS type PCBs. The first one is a copper metal substrate. This type of IMS board is pretty expensive and typically rare to find. I have a good example of one here in my hand. As you can see, it's a copper base with circuitry on top and then the copper exposed on the bottom to help dissipate the heat. It's very heavy and it's typically thicker than a normal PCB. These type of PCBs are used typically in applications where there's a high need for electrical and thermal conductivity. While copper is one of the best substrate materials, it's not immune to corrosion. The second IMS board is an aluminum substrate PCB. These type of IMS PCBs are commonly available and very affordable. Here's a good example of an aluminum IMS PCB. You can see here an array of LEDs that are designed on the primary side of the PCB, and on the secondary side is the exposed aluminum that you see to help manage and dissipate the large amount of heat that's generated from this circuitry. The aluminum metal substrate is a great alternative to the copper substrate, but the downside is that it has the common characteristics of a standard PCB. Aluminum substrate PCBs only offer standard electrical properties and thermal conductivity. The third type of IMS board is a stainless steel substrate PCB. When comparing the different IMS PCBs, the stainless steel is typically less expensive than the copper and the aluminum substrate PCBs. Stainless steel substrate IMS PCBs offer decent thermal and electrical performance. One of the positive attributes of the stainless steel substrate IMS PCBs is that they offer great mechanical stability. The main difference between IMS PCB and a standard FR4 PCB right off the bat is the heat dissipation factor and the fact that this board weighs several more ounces than a standard FR4. There are other differences between the two. In a standard FR4 PCB, you can mount through-hole components on a single layer board, whereas on an IMS PCB, you can't do that. Solder masks for standard FR4 boards are typically green, black, red, blue. There's an array of colors you can choose from, whereas on an IMS PCB, it's usually typically white. Another common difference between the two types of PCBs is that an IMS PCB, its fabrication process is a little different and requires using a saw that's coated with diamond blades to cut the material out, whereas a standard or a common FR4 PCB, you can use the mechanical techniques in order to get that fabricated. Another difference between the two different types is that IMS PCBs can only handle one layer of copper, whereas in a standard FR4 board, you can have multiple layers of copper. Due to the difficulty in producing multi-layer IMS PCBs, you'll find that they are the exception rather than the rule. One of the last things to note regarding the differences between the two types of PCBs is that in an FR4 PCB, there's not really any limit to the layer thickness. On the other hand, a thinner IMS PCB is not permitted. Thanks for tuning in. I hope you now have a better understanding of the value of designing IMS PCBs. Keep following along for more on trends, challenges, and opportunities within the printed circuit industry.